Good morning. So I am E. Lavenil, and now we are going to study equilibrium of particles, which is a continuation of this topic particle statics. So equilibrium. A particle is said to be in equilibrium if the resultant of all the forces acting on it is equal to zero. That is, it is a no force condition. So the particle tends to be in a position where it is not disturbed at all practically, and it is referred to as static equilibrium. When it comes to particle statics, the equilibrium becomes an essential condition because when the particle is not in equilibrium, there must be a resultant force which is available, and because of that resultant force, the particle would be moving, and we cannot study it under particle statics. So when we say it is particle statics, we study particles which are compulsorily in equilibrium. So it is often the reaction that brings the equilibrium condition, because normally we study when we apply some force, and then only we study the statics. That is, we study the effect of forces, and that is what is statics. So when we go for applying certain forces and still call that there is no net resultant force acting on a body, which means there must be some other force which is going to cancel out these applied forces. So when some other force that is cancelling this force with the equal magnitude, opposite in direction, at the same point of application, is nothing but the reaction. So it is the reaction that often brings the equilibrium. Of course, in very certain cases, we have a number of forces which have components which cancel one another, and finally, in certain rare cases, we directly have, without any reaction, the equilibrium condition is reached. So the condition for particle to be in equilibrium is the resultant vector is equal to 0, or sum of all the force vectors, or the vectorial sum of all the forces is equal to 0, which can be in 2D given as the components, sum of all the forces along x direction equal to 0, and sum of all the forces along y direction is equal to 0 by two separate equations, which in itself is a single vectorial expression. So in a static particle, the condition of equilibrium is invoked to solve for unknown applied forces or the unknown reactive force. Lami's theorem. So when three forces acting at a point are in equilibrium, then each force is proportional to the sine of the angle between the other two forces. This is referred to as Lami's theorem, which is a special theorem which can be used to apply when the total number of forces acting upon is 3. So here this theorem can be conveniently represented with the following expression: f1 by sine theta 1 is equal to f2 by sine theta 2 is equal to f3 by sine theta 3. Here the angle theta 1 is the angle between f2 and f3. Similarly, theta 2 would be between f3 and f1, and theta 3 would be between f1 and f2. When the total number of forces including a reaction, if there is any, is 3, we can go for either equilibrium equations or Lami's theorem. So equilibrium equations are that vectorial sum of all the forces equal to 0. That can also be used for solving. And Lami's theorem also we can go for solving the problems. So if there are more than 3 forces involved, we are forced to choose equilibrium equations, because Lami's theorem can go for only 3 forces. But there are certain cases with multiple forces where we consider 3 forces at a time and go for solving by applying Lami's theorem again and again and again. Okay, so either by equilibrium equations or by Lami's theorem, we go for solving problems and finding the unknown forces or reactions, and we study the force system on particles. Thank you.